All right, welcome back. Sorry I had to finish the last video fairly quick because the storm warning sirens are going off. We're all safe here, just thunderstorm warnings. That should be done here in a short while. But in the previous video, I pretty much finished off the requirements for piston and wall clearance, describing what difference it needs from a cast to a hypertonic with an additional heat treatments to it, to fully forged pistons. Now, all of that can be altered once again with piston coatings. So if you need to reduce the heat or the ability for the piston to reflect some of the heat, you can use a piston face coating. The skirt materials normally added to pistons is to reduce the amount of friction that's occurring between the piston itself and the cylinder wall. We're not going to get into the whole oil debate right now. We're going to try to keep this video fairly short because after the current videos that I've made calling out the engine oil manufacturers and so on and so forth, they have followed suit with confirming exactly what I've shared with you. Okay, so we're not going to get into that. It was covered in different videos that you need to understand how oils operate, and the tolerances within your engine, and which one's going to provide you the best protection, period. Okay, now here's an example going back to the original piston clearance issues that we've been observed on some of these YouTube content creators. Brent from Likens Motorsports. Now, I would bet that Brent is using some of the top oil that you can get. Okay, all right. He is not buying some of your conventional motor oils that might be purchased off the shelf at Walmart. I'd be willing to bet he's probably using a very high zinc containing oil with a lower viscosity to fill in the tighter tolerances of a race engine. Brent, if I'm wrong, go and correct me in the comments. I'm willing to bet you put some money in to the oil changes. Now, Broken Tool Garage, I believe, is the other one. Before I had to leave the last video, we were talking about the bull hog that used to be used in machining practices years ago. Opening the bowl itself, the same diameter is what or connecting to the valve guide, allowing the port to be opened the same amount, 360 degrees all the way around the port. But what we realize is that our ports are coming in from one direction. The airflow does not favor the entire bowl area, especially at different RPMs and within different valve lifts. Okay, so the older practices of putting a bull hog on a machine, opening those areas up, created a straight wall to the actual transition area between the seat and the rest of the port. It would work if the port was perfectly aligned to the point where it empties out directly into the valve, but that's not the case. And 99.9% of the time, that is not the case. So in the previous video, I said I'll give you an example, something that you guys can all relate to, something that has been proven within airflow research. Okay, so we can understand the transition from the cylinder combustion chamber to the seat, from the seat through the 1 inch of the transition from the seat into the port and within the bowl. Now, in order to explain and back up my thinking here, is I'm going to turn my board over. I'm going to flip it over so you guys can see it a little bit more without the flare. Okay, hopefully. All right, so now if we do this and we look at it upside down, okay? This is the drawing with the smooth transition from the combustion chamber into the seat, into the bowl area, and then into the port. What do you guys see here? With it flipped upside down, if I remove my arrow, what does that look like? Let me draw a little bit bigger. Does that look like anything? Or how about that? Previous videos I talked about the ventri. From the entrance point to the exit point, it all has to form a dual cone. The cone leading into the port to the smallest pinch point within the intake port to the expanding point into the into the combustion chamber. If you flip it upside down, it's the exact same thing as a carburetor with an air cleaner on it. So to verify my science behind this, you can tune into all the different YouTube channels that I've ever tested air cleaners. In almost every single circumstance, whether it's a velocity stack to a low profile air cleaner, say for something to be used with low hood clearance like a Corvette, to adding epoxy to the carburetor's choke horn, it's all creating a radius because vacuum pulls in every direction. It doesn't only pull in the direction of airflow. It is going to cause a negative pressure zone everywhere that it can. So if this is the carburetor and this is your air cleaner, the transition from the top of the ventries of the air cleaner into the air filter system itself, the joys of living near a railroad track. In every one of those studies, you will see that the air cleaner systems that use a radius from the top of the carburetor into the air cleaner system itself will always have the greatest flow. So now again, we'll flip the board upside down. And go back to these two drawings. This one being a port that has received the straight wall treatment, whether it's through bullhog or hand porting. This would be the design where the bowl is still 100% of the valve diameter. So from the diameter of the valve, the exterior of the tulip itself, in comparison to the seat, the area where the seat crimps in onto the port, to the bowl area, it returns back to 100% of the diameter of the valve. So if you install larger valves, say from 194 to 202, your bowl width from the short side to the roof of the port should be the same, if not bigger, than the valve. The cross-sectional area that created by the seat, that should also be 90% of the total valve diameter. Not just the valve seat diameter, the valve diameter. But you still need to have that transition creating a radius. Because once again, just like the air cleaner, when we flip this upside down, the vacuum being pulled in by the cylinder, the negative pressure within the cylinder, creating vacuum, drawing on the intake port, works the exact same way as the air filter or air cleaner system leading into a carburetor. Now, even the combustion chamber, how it's meeting up to the valve seat, that also has to be a radius. Some of the castings, they'll actually, be formed. Machinists will come, open it up to put in the hardened seats into it, and they'll bury them to the point where the material of the casting of the head is either way forward, protruding from the seat, or will be sucked in to be actually deeper than the valve seat material itself, or excuse me, the seat ring itself. You want to have a perfect transition. Whatever happens in front of the valve or behind the valve should be exactly what occurs from the valve seat, your seating surfaces or mating surfaces between the valve and the seat, into the combustion chamber. that will allow the vacuum that is being created to pull in the maximum amount of air. The straight wall practice does not allow that to occur. If you go to a 88 or 90 percentile opening of your bull hog area or your hand ported area, you have the pressure zone. As air is flowing, even the vacuum, it will create a barrier. You add that in there to when the high velocities occur on a straight wall, your port is effectively becoming smaller. Even though you've removed material, just because of the shape and the you have to excuse me, I'm forgetting the technical term. The pressure barrier created between the surface and the flowing air is actually going to be smaller than the material you just removed. So if you were shooting for 88% or 90% and you go to a straight wall, you might only be getting 82% of the total area, subtracting the pressure zone. So in essence, by removing material, if it's straight, you're actually making the port smaller. So again, depending on who you're talking to, who's sharing their advice, make sure you know truly what is happening with an airflow. Now, to take this a little bit further, because our ports are coming in from one side normally, the airflow velocity and the fuel path is not going to favor the entire diameter of the valve. It is going to be directional. So most of your higher velocity airs, okay, being pulled in by vacuum, will travel with the least amount of resistance. Makes sense? You can try to direct the air. You can try to direct the vacuum, but it's only going to be able to turn a certain amount. Easily understood. The fuel will normally concentrate into that area, or you want at least the larger droplets of fuel to move into that higher velocity portion of the port to allow a better distribution into the combustion chamber itself. So by unshrouding the valves, yes, you're allowing more of that vacuum to be shared 360 degrees around the valve itself. But unshrouding the valve on the tight side, the cylinder wall side of things, you're also allowing more vacuum to be drawn on that side of the port. It is not addressing the area with the maximum amount of flow. So even though our valves are round and the seats are round, the airflow occurs on one side of the bowl or port area, normally the roof. So by making a straight wall combination here, you're killing flow. You're allowing more volume to occur, so the ramming effect is going to have more. But those straight walls are also going to allow the reversion to be exposed to the bowl area in the same fashion as air being pulled in. With the ventri effect, okay, it has to squeeze into a tighter area. The reversion does. And then open up once again. It's a hiccup or blip or burp within the system to restrict airflow from reversion back into the port. It allows more room for the intake charge to fill for the ram effect. By creating a straight wall, either by machine or hand, you're defeating the purpose of the work for the trade-off of power. So again, for your typical do-it-yourselfer, getting in, diving in, and trying to do things with your own hands, with your own tools, it's admirable that you're trying to do the things yourselves. But the experience accumulated with turning to a professional, somebody that can back up the flow numbers and show you the practices on equipment that they have already, is well worth more power than what you probably have from catalogs and so on and so forth. Okay, so again, karma, as I started out with this series of videos, the individuals that are sharing some of this bad information, the karma is finding them. Whether in bad weather, to lost business, to engine failures, and even customers coming out and being able to say, we actually know more than what you're saying. That we're sending stuff into you to be assembled, to be modified, so on and so forth, but it's actually coming back worse than it was before. Okay, so be aware of that. Without touching the bolt area whatsoever, as far as opening it up, changing it to 88 or 90 or 82%, by simply going to a larger valve, you're creating a larger radius because the valve's bigger in diameter. The seat also has to be ground with that larger diameter into it. It is still retaining the radius between the seat and the bolt. Without having to touch a grinder, you can increase flow. With a larger valve, you're also going to be filling in the area of the cylinder wall side of the valve. So you're going to be filling in the restricted area that most, like David Vizard or Charles, with the flow balls, yes, you're going to get more vacuum to that side, but that's not where the most current of airflow happens. You're actually taking some of the vacuum away from pulling on the side where the most air actually transfers through. So increase in valve size and do not deshroud the valve. You will actually see a larger flow within air than if you were to actually deshroud the cylinder side of a combustion chamber. You're also going to retain the compression. So without doing these modifications promoted by some of these YouTube content creators, you're actually going to realize more power. Remember the sales pitch. If you don't have the tools to do it, you send it off to somebody else, they're going to back up their theories and their machining practices according to what they say, because they're making money off of you. If you want the most amount of power, trust what the engineers, the original engineers from the 1940s, 50s, and 60s have already designed into it. Remove the factory casting flaws that happen in high production, but trust in the original designs. They have millions and thousands of hours of R&D into one single design. One guy in Oklahoma or in Virginia or in Texas does not change that. So with that, piston clearances, again, hopefully Brent, anybody that's watched with Brent Lakin Sports, he is a very high-end engine builder, okay? He does things right. He pays attention to detail as far as the components. He doesn't cheap out on things. So I enjoy watching his stuff, still to this day. A lot of the Ford stuff I don't mess with, so I'm learning the Ford aspects of the performance stuff. But even an engine builder that has been doing this for a while can make mistakes if they're reaching out to manufacturers and taking their manufacturer recommendations. Okay, it's um, it's bad. It's really bad. The aftermarket or factory refurbished equipment industry is nuts. Replenishing your original equipment to be refunctional is always going to be the best route. Don't look at remanufactured stuff. If you know parts are being remanufactured, stay away from them as much as possible from the high-end remanufacturing plants. Any of your core transfer stuff, try to stay away from as much as possible. Go with original equipment and modify it from there. With that, have a good one.